Hello class, my name is Cindy Shelton. I'm your instructor for your Math 110 class online, and I'd like to go over some of your questions for your midterm study guide with you. So I'm going to start with Chapter 1, the reasoning chapter, the applied problem-solving chapter. We have two types of reasoning, inductive and deductive reasoning. Inductive reasoning is where we look at a pattern and we assume what's going to happen next, but we're not absolutely certain. We're only making an assumption. Deductive reasoning is where we can mathematically prove it with an actual formula, and we'll see a problem like that later in our study guide. The first question on your study guide, we see this pattern, and yours may be a little different on Math Excel, but this is an example. We have 9, 3, 1, 1/3, 1/9, 1/27, and so on, and we're predicting the next number. Actually, your problem stops at 1/9. And then we're supposed to predict the next three numbers. So it looks like we're dividing by 3 each time. 9 divided by 3 is 3, 3 divided by 3 is 1, 1 divided by 3, and so on. Another way to think of it is this is 3 to the second, 3 to the first, 3 to 0, so the exponent's going downhill. So either way you could think of it, I would predict the next problem would be 1/27th, or the next number in the series, 1/81, and I hadn't worked the next one out, but 1/243. Okay, number 2. And again, this is your midterm study guide. Number 2 asks you to predict the next number in the sequence. You have a 16, 25, 36, and 49. Those look like the perfect squares to me, just assuming, again, that's how inductive reasoning is, just looking at it and saying, what pattern do you think you see? This is 4 squared, 5 squared, 6 squared, 7 squared. So I expect the next problem to be 8 squared, or the next number in the series to be 8 squared, or 64. Okay, number 3, we switch to deductive reasoning. So they start us out with looking at the pattern and seeing what it looks like is happening, and then we actually prove it with algebra. Okay, it says repeat the following procedure for 4 given numbers. Okay, on my problem it says to add 5, double my result, subtract 4, and divide by 2. And, well, 5 steps, subtract the original number. Okay, so we're going to repeat these 5 steps with these 4 examples and just see what we think's happening, kind of inductive reasoning, and then we're going to switch to deductive and prove it. So, my first problem says, do this with the number 2. So, number 2, follow these steps, add 5, it's 7, double that number, 14, subtract 4 is 10, divide that by 2, that is 5, and then subtract the original number from that. The original number was 2. So 5 minus 2, we get the result of 3. So we plug that in on Math Excel that we get 3 with that process. Okay, then we do that again. The next problem, it says do that with the number 5. Add 5 to that, so our number 5 plus 5 is 10. Double that number, that's 20. Subtract 4 from that number, 20 minus 4 is 16. Divide that number by 2, 16 divided by 2 is 8. And subtract the original number from that. The original number, remember we started out with a 5, so 8 minus 5 for a result of 3. Now remember, last time we did this, we got 3 as well. Okay, so right now it's looking like I'm getting a 3. Try it again. So we do this with the number 7. Add 5, 7 plus 5 is 12. Double that number, so times it by 2 is 24. Subtract 4 from that number is 20. Divide that number by 2. 20 divided by 2 is 10. Subtract the original number from that. Remember the original number is 7, so 10 minus 7, there's 3 again. I'm thinking I'm going to get 3. And I won't do the 4th example, but you would do that on Math Excel. I'm going to go on down to B part, where now we do the inductive or deductive reasoning and represent the original number as n. N is algebra, meaning that n could be any number, and then go through this process and show that we still get a 3. So take any number n, add 5. It looks like n plus 5, and they do step by step on Math Excel, so you fill that in. Then the next step, double that, so twice the quantity n plus 5. So we would need to distribute and call that 2n plus 10. And then the third step, subtract 4 from that. 2n plus 10 minus 4 would reduce to 2n. 10 and minus 4 would reduce to 6. 2n plus 6. Divide that by 2. 2n plus 6 divided by 2. Now remember, both of these parts are divided by 2, so the 2n over 2, the 2's will cancel and you'll just have an n, and the 6 divided by 2 will be 3. So we get n plus 3. Then the last step is subtract the original number. The original number in this generic case is n, so n plus 3 minus n, the n's would then cancel, and every time you have to get a 3 when you go through this process with every number, and so that proves that deductively. Okay, so that's chapter 1. Well, actually 4 is still in chapter 1, 4 and 5. It's using the idea of a proportion, but we kind of switch gears. We're using proportions on number 4 and 5. It says on a map, 1 inch is equivalent to 19.5 miles. Then it says if two cities are 4.5 inches apart on a map, how far are they actually apart? One way you could do it is just thinking through that, know that that means every inch is going to be times 4.5, and that's fine if you do it that way. But I want to demonstrate the idea of a proportion, that if you can say inches to miles is equivalent to inches to miles. Kind of compare like things in a proportion. How many inches for a mile? How many inches for this mile? So 1 inch is given is 19.5 miles. So 4.5 inches is how many miles is our question. So in the proportion, once you see you got inches to miles, you can kind of drop out the units and say 1 is to 19.5 as 4.5 is to what? So if you set up a proportion that's a fraction equal to a fraction, the cross products have to be equal. So you can cross multiply. 1 times x, or just x, 1x and x, same thing, has to equal 4.5 times 19.5. So I'll take my calculator, multiply that together, and get 87.75. And that should represent how many miles, actual miles, that would be. Our problem says to type as an integer or decimal, and double check my answer key to see if they wanted us to round it to any particular place. We always have to watch our rounding on Math Excel. It should give you specific directions, and we need to make sure we follow that. So it did not tell me to round, so just leave it as its full answer. Okay, number 5, we're going to do that process again, proportions. Number 5 says, when a fence 8.6 meters high cast a shadow 7.3 meters long, how long is the shadow cast by a person 2.1 meters tall? So again, we can compare shadows and actual height together. It should be proportional if it's the same time of the day, same angle of the sun, we're assuming. So this is another proportional situation. So it says a fence that is 8.6 meters high. So this is an actual object casting a shadow 7.3 meters long. So this is actual over shadow. So on this side, we want to have actual to shadow, comparing the like things. Remember, like on the last one, whatever we have in the numerator here should be in the numerator here, comparing like things to like things, proportional things. So we've got actual 8.6 to shadow 7.3. So how long is the shadow of a 2.1 meter tall person? So that's an actual distance of a person, 2.1 meters tall. And we're looking